Welcome on our meetup. Nice to see you all. Today, Anna will be presenting a workshop about testing React, how to test React basically without rendering anything, and how to nicely separate logic of the application from the front-end design, in a nutshell. I will remind once more that we are recording this meetup, and it will later on be available on our website and YouTube channel. And if you have any question during discussion, during presentation, you can ask them on the chat or just speak. It will be great to hear from you. So Arnaud, you ready?
Yeah, sure.
Cool. So I'm passing this to you.
All right. So I'm going to share my screen. Blind Outside-in TDD in React. So what are we going to do? So I'm going to give a quick introduction on why I felt the need to do some Outside-in TDD in React. And we're going to go through common issues when it comes to testing in React and see what could be the cause, what could be a solution, for instance, Outside-in TDD. And then we're going to code. So the first part of the coding session will be blind. So we're not going to open our browser. We're not going to start React nor anything. We're just going to write some TypeScript codes and implement all of our front-end logic. And on during a second session, that will be way shorter, we're just going to add some Bootstrap, some CSS quickly and start our application. And normally, everything should work on the first try. So introduction. So why testing can be difficult in React and what could be a solution? Just a small disclaimer. So I'm being very cautious with the words I'm using. So what can be difficult or what could be a solution? The reason for that is that it's really experimental. So I don't want anyone to arrive at the office tomorrow and refactor the entire test suite just because OCTD looks cool. So it's really helpful. It's really nice to do as a kata in a meetup workshop. It really helps in understanding what we're doing in React, what we're testing. Now I haven't tried it on a real project. I don't know how well it scales or even if it can scale at all. So just be cautious with that. It's quite interesting, but yeah, don't use that by default. So testing in React. When I started to learn React, which was, well, 9 months ago, I was at the same time learning about TDD, about Outside-in TDD, etc. So when I started to learn React, I almost immediately looked at how we could test, how tests were made in React. And I was really struggling to test in React. I've discovered many tools. I've discovered many ways of testing things. But in the end, I wasn't happy with the results at all, actually. And I couldn't really understand why I was struggling so much writing my tests. So I just took a step back and I tried to ask myself, OK, so what's in a React application? Well, we have some states. React is known for its states. We have some API calls, for example, when we need to populate these states. We need to process some data back from the API in order to put it in the states. We're going to consume our states. So we're going to have some conditional branches, render some stuff if we're logged in, if we have an admin, some sort like this. We have user interactions. So there are many asynchronous events. So there are many, many different types of complexities in React. And actually, when we look at this list, this is not really specific to React, nor even front-end testing at all. That's just common to any kind of application, like backend application, but just almost any kind of application. So this complexity that is known, that is non-trivial and that is usually well tested in other applications. I was struggling to test it in React. I couldn't understand why. And the reason is that the list is incomplete. Because we're in the front end, we introduced the notion of UI, of design. And for instance, in React, we have components. So components are going to interact with each other. Components are going to contain the rendering codes, which will render the UI. So we have even more complexities than in normal applications. And to me, the only logical consequence of that is that we should test even more in React than in a classic application, a backend application in JavaScript, in Java, or whatever the language is. But that wasn't the case. I was struggling to write my tests, and I was seeing many people not writing that many tests at all, in fact. And so in my experience is not large, but I have some experience. Every time we were talking about front-end testing, people were just talking about UI testing. And I think that was one of the main issues that I came across in projects, is that when it comes to front-end testing, people are talking about Selenium, about QFT, or about many other tools that will tie your tests to the UI and only the UI, which means that anything around this, any sort of logic that could be contained in your front end, so getting data, processing data, rendering data, many things that aren't necessarily related to front end, many complexities that aren't specific to front end, they will be tightly coupled to your UI, and they will be a bit like underlying, and they will be tested implicitly through the UI, but they won't be tested explicitly. They won't be first-class citizen in your code, and this is an issue to me. So as said, when I'm struggling to write a test, I'm always asking the question, okay, what am I testing? And when I looked at my React code, I realized that I was giving many, many answers to this question, which is not necessarily wrong. It is not necessarily wrong to test multiple things in the same test case. When it's simple, simplicity might overcome the fact that you're testing multiple things. But then in React, the code wasn't really simple. And when the lack of separation of concern is impacting my tests, when I'm struggling to write tests because I cannot properly test my responsibilities. So when I say testing properly, it's when I have 10 or 20 lines of test setup because I need to set up 3 different components so everything works at the same time so I can test one path. This to me is not properly testing things. It's hard to maintain, hard to write, to read. So the real idea is to think about the design again and try to address this separation of concern issue. So what could be a solution where there's a principle that is this single responsibility principle? Again, I don't want to look a bit to say that it's a rule that one must follow all the time. Overextension of this rule might be more destructive than not having it. But in React, I found this rule often forgotten, this principle, often forgotten. And I think that having tested to follow this principle as a rule, it makes testing so much easier and so much enjoyable that I found it, like usually when I'm trying to test, 99% of the time, the reason I was struggling to write the test was because I was testing multiple things. So the idea today is try to think of the design of responsibilities of what we're testing in React, and see how we can improve this. And the way to improve this would be Outside-in TDD. There are many articles that you can find comparing classic TDD and Outside-in TDD. And there was one that I found actually this morning that I found very interesting, saying that TDD wasn't leading to a good design, and the main issue was looking at the solid principle was the lack of single responsibility principle. Because if you follow single responsibility principle a bit blindly, you might have some damage somewhere, but your design, the result, the end result, will be extremely easy to test because things will be small, focused on one and only one responsibility. And so the Outside-in TDD to me is a really great tool when you're struggling either to design your code or test your code, because it was really drive a design, really help you in designing small and focused components. That's the reason I decided to try that in React in order to improve, or at least to better understand what I was testing in React. So let's move to the codes. I prepared a very small, I don't know if you can move that, yeah. So here's the kata. So on the right, you can see some three windows. So this is the application we're going to try to implement. So we just have a single button. When we click to this button, it's going to fetch some data. While fetching, we'll have a loading spinner. And when the data is ready, we are going to display all the items in a list. So that's what we're trying to achieve. For that, we're going to use React. We're going to use Typescript as well. So Typescript here is configured to be very lenient, just because I didn't want to have pollution during the kata. So we stay focused on the test, not on the types or whatever. So I will almost not, I will almost write classic JavaScript code for that. The reason I'm using TypeScript is because there's a cool mocking library in TypeScript that I really like, and I didn't find an equivalent on JavaScript. So what we're going to do, I have well, everything already implemented, and I have everything on commits. So I'm not going to write any codes. I'm just going to go through each commit, explain a bit what we're doing. And if there is any question about anything, we'll be able to go back or move a bit faster if we shorten time. So please leave a message or just speak if you need anything. So let's start with our acceptance test. So in Outside-in TDD, we're starting with the acceptance test that is going to drive our implementation. So our acceptance test is just going to test this workflow. So we're going to create our root component, which is the app. We're going to inject our data API, which is going to, well, contain the data eventually. In terms of library, by the way, I am using the React testing library, which is more like a black box library, like it's following the black box approach, which is very great for the acceptance test because we don't really care about the implementation details. We just want to mimic a bit what the user is going to do. So I'm going to use the user events tool from the RTL, which is extremely nice, to click on my fetch button. And then we're going to find two components with the test ID item and expect that we have two items and that they are correctly displayed and visible on the UI. So I just executed my test. So in terms of implementation right now, I just have my main components and my data API. So every time I'm writing a new component, I will just write an empty component and throw immediately an error. That way, our acceptance test is going to drive us to tell us exactly what is the next step to implement in order to make our test pass. So here, the first thing when I run the acceptance test is going to fail because I don't have my main component implemented. So we're gonna jump to this app components and we're gonna write our first test. So now we're moving away from our acceptance test and we're starting to design our main component by a unit test. So here, the idea is to define what is the responsibility of this very component. So this is my root component, and this is where my state will be located. So the responsibility of this component will be to hold the state, to update the state, and to pass this state to another component that will render it. So here we're really focused on state management. So I'm going to run this test, which is going to fail because there's still no implementation. In terms of library, I am using Enzyme. So Enzyme is slightly different from a React testing library. Enzyme is more is following the white box approach. So Enzyme will allow you to find components that have been rendered, to look at their props, to look at their states, which, if you look on the web, is considered as a bad practice. But when doing Outside-in TDD, it is important because what you want is completely isolate your component from the others. So you want to see how your component is interacting with its child components. So here it's exactly what we need, because we want to know with which props are we rendering our child components. So our application, it should not contain any items nor be in a loading state by default, which means if we go on the right, which just is mapped to our default state, which is we just have one button with no loading and no data. So we are going to shallow our app. The reason being we want this to be completely isolated from anything else. We don't need to render children's. We are going to mock our data API. For now, we're not using it, but at some point we are going to use this mock to set up some fake data. We are going to then to find the main section. So the main section is going to be the child component that is going to be rendered using the state, and its responsibility will be rendering. So we're not specifying its construct now, but just saying that this will be the output of this component. And then this is the state, so loading to false and 0 items. So we're going to add some implementation, run the tests, and look at the app. So here we are just simply declaring our default state, and we are rendering this main section. Not that I'm using a class component. There's a reason for that, because I found class components very handy to test state, but there are many alternatives, and you could do it in a function component as well, but I do like class components for that. So this is our default state. Our unit test is passing, but we're not done with the responsibilities of this main component. Now that we have a default state, we need a way to provide a callback so that state is updated, because at some point, we'll have to give this callback to the button, so when it's clicked, it will update the state. So the next step will be, it should provide a fetch callback. So we still have the same setup, the same action where we get the main section. And this time we're just asserting that we are rendering our main section with our fetch callback. So the implementation is extremely simple. We just add an empty callback for now, and we are rendering it. We are passing it to the main section that will eventually give it to the button. Now that we have our default state, now that we have a way to update this state, so we're going to design our state transition. So when someone will click on our button, we're going to fetch the data and display a loading spinner. So here we have multiple things in this test. So now we are going to use our data API. So we're going to mock it, and we're going to return a new promise. So this promise will never resolve. This is in order to simulate the fact that the data is loading. So that way we can safely do our assertions. We don't have to manage the asynchronous event. We don't have to return real data and do our assertion on time before the data is ready. Here we know that it will be loading forever, which would be super simple for our test. And we're gonna trigger the event by simply calling our callback. So here we're doing a simple fetch. And we're gonna assert that once we call that, the main section is going to be rendered with a different state. It will be rendered with the loading state. So in terms of implementation, the implementation can be extremely simple. It's just when we call the fetch method, we render a state. Note that we don't even have to call the API because whether it's loading or not, this implementation is simple enough to make our test pass. So we're just gonna implement this simple test. And now, so we are in this intermediate state where the data is loading. So we need to implement the final state where the data is ready and we're gonna render these items. So, oops, I lost this. So here we have a new test, which is should render the data once available. So here, the difference between this test and the previous one is just that we're gonna resolve our promise with some data. We're gonna fetch it, and this time we're gonna expect not to be in the loading states, but to have some items being generated. So in terms of implementation, it's again very simple implementation where we simply call our data API and then in the promise, consume the promise and update our state when the promise will be ready. So here, if we look at this view, we really, for the app, we want this app to manage the state only. And if we look at our tests, then we have a clear description on what is the default state and what are the possible transitions to this state. And this is the only responsibility that we want for this class. And this is already complex enough to be encapsulated in, not encapsulated, to be separated from the rendering. So when you have complex states, it can be nice to completely decouple it from anything else but state, and to have this, this class component focused on it. So I'm happy with this class. I'm happy with this state management. So now what I want to do is go back to my acceptance tests and rerun it. So the key in Outside-in TDD is really this acceptance test where once you're done with the units, you simply rerun your acceptance test, which will tell you what is the next goal. And so here we've done the application, the app component with the state. So now the next target is the main section that is going to render our state. So we move to the main section and we write our first test, which is should render the query section if no items and not loading. So the query section is a section with a button, and no items and not loading is actually our default state. So the goal of this component is really to take a state and transform it to, and render it, basically. So we could have this moved up move it at the same place than the state management, but it would be two responsibilities merged into a single component, and we would have to merge all our tests and to do both setup at the same time in order to test everything. Whereas here, we're really trying to focus on getting a state and transform it to some components, which will make our test very easy and our component extremely small in the end. So in terms of implementation, we're still with the enzyme, with the same white box library. And this time, we are going to assert that when the main section is rendered, not in loading state and without any item, is going to render a query section and provide our fetch callback. So the implementation is quite simple. I can even jump here. So the implementation is trivial. We just render our query section with a fetch callback, because right now we only have one test case. Then we are going to render our second state, the loading state. So same, very simple. When it's loading, then we should have a loading section to be rendered. So implementation, trivial as well. We just an if statement and we render our thing. And we do the same for our third state, which will be as trivial. Should render the item section if not loading an items present. So here we have some items. We have exactly the state we described. And we expect to have an item section with the correct props. And so we end up with another if statement in this component. So in terms of responsibilities, again, if I look at the final code, I just have 3 branches. It's almost like a router, basically. But it's really, this responsibility is taking the state and rendering the correct components and nothing else. And this is why this is a 10 lines components, and tests are also extremely easy to write, because it's really focused on this responsibility. So I'm happy with this main section. So I can come back to the acceptance test and run it to see what is the next target. And the next target is the query section. That is the section with a button. So we're gonna go and implement that one. So the query section, it should render a fetch button with the callback. So here, we're not with enzyme anymore. Reason for that is, what is the responsibility of this component? Well, this component is going to actually render some DOM elements. It's going to render the button. So here, I won't have any collaborators. I won't have any child components, or at least any child components would be just details about the UI and how the UI is designed, but there won't be any responsibility in our front-end logic. So this is why we switch back to React testing library, because it's simply easier to test user interactions with this. So we're going to render our query section with a callback. This callback will be mocked, and we're gonna find a fetch button on this component, click on it, and assert that our callback has been called. The implementation is actually not with the button, but with a div. So this is the blind part of the Outside-in TDD. So we are just going to render empty divs. We're not going to focus on what is being rendered, because this is not our responsibility. This is not what we're trying to test. We don't really care how it will look like. We just care that we have an element that is clickable, and when it's clicked, then the callback is called. So we're gonna keep this div for a while and only change it at the very end in the second part to actually see our application. So that's actually the only responsibility for the query section. We just have one button, we click on it, and that's it. So we can go back to our acceptance tests and run it. So I'm not running all the tests all the time, but unit tests are green, like I went through them. They're all green, trust me. So what is the next step here? Like, I would have been tempted to go to the loading section, because it would have been the next natural step or screen to implement. But because I'm driven by my acceptance test, the next step here is when I click on the button, I am fetching some data from the data API. So here, it's quite interesting to be driven by what actually happens in the workflow, rather than just us thinking of what is the next step. So here, the next step is the data API. Because I really want to be focused on React, The data API will be extremely simple, so we won't spend much time on this test. It will be just a simple JavaScript class that is going to return a resolve promise in 2 seconds with 2 items. So it could be like even the test is a bit optimist because I say that it should always return 2 items in less than 5 seconds. 5 seconds is because I know that test will fail if it won't be resolved in 5 seconds. So here the test is a bit weird, but that's just because I don't want to spend too much time on pure JavaScript code. So we just have an API that will always return 2 items, and that's basically it for this responsibility. So if we rerun our acceptance test, now the next step is the loading section. So the loading section is a bit interesting because what do I have in the loading section? What are the responsibilities? Well, there is no actual logic in this loading section because the loading section is really about rendering this loading states. But I'm not really interested in the design. I'm not interested in this. So the implementation is actually just an empty div. And there's no need for unit test for that because again, I wouldn't know what to test because I'm excluding anything related to the UI, the design, the layout, etc. So the loading section is actually free to implement, and we can move back to our acceptance test and move on to the next section, which is finally the item section. So this item section is the final section. What is the responsibility? Well, when we have, that's not the item section. The responsibility is it should render 1 item and it should render multiple items. So basically it's just have a list and I want to render them. In terms of testing, here, note that I don't have to mock any API. I don't have to think about how I retrieve this data because this component is really about rendering only. Then I just create a new list, and it's way, way, way simpler to think about this rather than having to set up the mock, having to understand what's the internal logic to display all of that. Having these small focus components here allow us to always have a test that can be written in 5 lines, basically. So here, a very simple implementation. I will just render them over a map with an empty div again, because I'm not interested in the front-end layout. And so now if I run my acceptance test, the acceptance test is going to be green. So what happened in the acceptance test? So we're clicking on the button, we're fetching some data from the data API, and we're rendering each items in a component with the test ID item. And that's about it for my front-end logic. So I still haven't, I mean, I could start my application. I only have empty divs, but that's not really an issue, actually, because we can simply go to the console. So if I open this, I can see that my fetch button is here. And if I copy it, if I click on this fetch button, then at some point, I will have 2 items. So my website is here. We cannot see it, but all the logic is implemented and things are working correctly as expected. So this is the first part of our coding session, is to implement all this front-end logic using either React testing library or Enzyme to render our components. And so now we have a last responsibility, is a last objective, is just to have some layout, some UI, have something to see on the UI so we can actually use our application. And so here I'm going to introduce another tool, which is Storybook. So I'm adding stories file, And I will start Storybook in the same time. Storybook, it's a tool that allows you to write stories for your components. And it's extremely helpful if you're trying to have some sort of component library. It's very handy to have this library, this catalog of items, and try to to write stories about them. So if I open this, I have one story per section. I have my main section, I have item, loading, and query section. And so for now, because we don't have any implementation, everything is empty. But in my stories, I can already define a set of properties to represent my state. So for example, the main section, if I go back to my wireframe, so I have 3 different windows, and I can write one story for each window, one when the data is ready, loading data, and the default one with the button. For my item section, so the third screen, I can write a story when I have multiple items, but I can also write a story when I have 0 items or 1 item. And having all these examples of usage for your components is great when you want to build, a library of components, but it's also great as just a daily tool when writing your components and writing the design. So here, if we take, for example, the item section, so here is an example of story file. It's extremely easy to write. You just export your components with a set of props, and these components will be simply rendered on the right-hand side of the screen. So if I add, for example, a very easy implementation of the item section, you can see on the right that it has been updated with the default implementation. So I just took some Bootstrap components just for the examples. And we can see how it looks like with no item and with 1 item. And so the good thing with this is in terms of, so here I'm trying to have a good design, a good UX, a good layout. And here it makes visual testing extremely quick. Like the feedback loop is extremely quick. And not on only one scenario, but on all possible examples that I can find. And we can see that here so if I open the implementation, it looks fine when you have multiple items, but it's a bit weird when I don't have any items, for example, or even 1 item. And so this kind of feedback, I found it extremely great because it allows you to see in a glance how it looks like. And so you can really try to find the good stories for your components and show exactly even to people how it's going to be when they will use it. So, and having small focused components allow you to write these stories very easily. Because if you have everything, if you have data APIs, if you have state, if you have logic in it, then it becomes extremely hard to write stories for your components because you'll need to mock things, you'll need to set up data, and it will make experience a bit painful. And so I found Storybook extremely helpful and really taking advantage of the single responsibility principle in the end. And so here I added some implementation, some CSS for the rest of our application. And we can see that we just know exactly what we have. So if we take our workflow in the end, our watermark on the right, we have implemented it in Storybook as well. And so we have examples of each component with different stories. We have our query section, we have our query button. And in the codes, if I go to the query section, for example, so I really just replaced the divs by just a Bootstrap component. So I didn't change my tests. I didn't change the logic, the front-end logic. I just implemented and implemented the layouts, basically. And so right now, if we stop Storybook and if we restart our application, so we have the same logic, but this time instead of using the console, then we can just click on the button, see the loading spinner, and finally the data. So that's actually about it. We've done some Outside-in TDD. It was completely blind at first because we were focused on the front-end logic. And at the end, when everything was, all the interactions were ready, we were able to just think only about the design, and it was actually very easy to just add the design, reuse components, because they were just focused, all these components, they're just focused on rendering, and they don't really care about state management, about API, about anything else. So yeah, if you have any question, if you want me to go back to any point in time, or if you just want to share your experience in while testing in React or writing React codes, if you ever tried TDD or Outside-in units, feel free to share, and thanks for listening.
Thanks a lot, Arnaud. Does anyone got questions, or we want to start with the questions from the chat? Arnaud? On the chat, we got one question. I believe it was answered later on during the presentation. It's from Martin. So question is, we just want to check the behavior of the code and not what's rendered, but shouldn't we also check the content of what is rendered? But I think in your structure of presentation, this was answered. Do you want to maybe expand a bit here?
Yeah. Yeah, that's a good, because for example, if I take my item section and if I swap both values, that would just be wrong. But for this, so there was a third, like another tool, which is snapshot testing. And so basically, in terms of workflow, the idea is to start with just the logic. Then you open your Storybook or your favorite tool for that. You start designing it. You start writing, adding the CSS, the HTML, etc. And once you're happy with the results, you're testing it, you're visually testing it through Storybook, for example. And once you're happy with the results, then you just save it for your snapshot testing. And then you have the comparison, like on every build, you'll have, they will compare either the DOM. You can also do some, you have screenshots, and then they will compare screenshots as well. To me, this responsibility of testing, is quite hard to have it automated, because it can change frequently and it can break very easily. And so snapshot testing and this comparison, I found it well suited for this purpose. Because that's something you really want to do manually, and yeah, I found it a bit hard to automate it in the code, because I found it a bit too close to the code to automate.
Okay. Any other questions? No? Sure. Okay, in this case, thanks once more, Arnaud, for workshop and presentation. Great job. And thank you all for participating in our meetup. Video will be available soon on our website. And hope to see you soon again on our next one. We have presentation next week ready for working with legacy code using the golden master technique.
Cool.
Thanks a lot.
Thank you, everyone.
Yeah. Have a great evening.
See you next week.